Since force is a vector, we have to derive Coulomb's law in vector form. So this is very easy concept. For that, consider same two charges. So here Q1 is one charge and Q2 is another charge. And then here we have to mind the force. As usual, they are at a distance of r. What happens? The charge Q1 applies a force on Q2 along in this direction because they both are positive charges. So the force on Q2 due to Q1, that we will write in this notation. F2 1 the direction, that is force on Q2 due to Q1, that is in this direction. Similarly, Q1 also exerts a force on Q2 along in this direction, that we will represent F1 2 bar. It means force on Q1 due to Q2. So these two forces will exert a repulsive force because of the similar charges. And we will represent the force separately now. I would like to write F21 bar, which is equal to force on charge Q2 due to Q1, is equal to same formula 1 over 4 pi epsilon naught Q1 Q2 by r square. Now here I want to represent precisely the unit vector direction. It is in the direction of r12 cap. So r12 cap direction along in this direction. Force on Q2 due to Q1 is in the same direction. The unit vector direction r12 is along in this direction. Similarly, if we write F12 bar equal to force on charge Q1 due to Q2, write the same formula 1 over 4 pi epsilon naught Q1 Q2 by r square. Here the unit vector is in this direction r21 cap. If I show the unit vector here r21 cap, that is along in this direction. Okay, now these two forces are equal in the magnitude, but only the difference is they are separated at a, they are opposite in direction. So if you replace r21 cap unit vector definition, according to unit vector definition is vector by its magnitude is known as unit vector definition. So we can replace r21 cap is equal to minus of r12 cap. because these two unit vectors are the same in magnitude but opposite in direction. Therefore, if you can write like that, f12 will changes as minus 1 over 4 pi epsilon naught q1 q2 by r square into r12 cap. So this quantity I will replace with f1 2 sorry f21. That quantity I will replace with f21. So finally f12 bar force on first charge due to second equal to minus of f21 bar. It means these two forces are the same in magnitude but opposite in direction. This known as vector form of Coulomb's law, because force is a vector, so it's supposed to represent the direction. Let's see one NCERT example problem. The problem is, if a body gives out 10 power 9, we take just as 10 power 9, 10 power 9 electrons every second, how much time is required to get one total charge of 1 coulomb from it? So think the problem like this. I'm having a tank full of charge 1 coulomb. This tank contains 1 coulomb of charge. So in this tank, electrons are the flowing. How much it is flowing? In 1 second, 10 power 9 electrons are flowing. So in this 1 coulomb of charge tank, in 1 second 10 power 9 electrons are flowing. So I want to calculate what would be the time required to empty this tank. That's the simplest way I was thinking. So to solve that, number of electrons given out by the body in 1 second. So in 1 second, the number of electrons are given out equal to 10 power 9 electrons. So I want to calculate charge given out by the body in 1 second. Charge given out by the body in 1 second, charge Q equal to NE. So charge Q equal to N. In 1 second, how many electrons are there? 10 power 9 electrons. 10 power 9 times charge of electron 1.6 times 10 power minus 19 coulomb. So the amount of the charge is equal to 1.6 times 10 power minus 10 coulomb. It means in 1 second this much amount of the charge is leaving. So now the problem becomes simple. In 1 second 1.6 times 10 power 19 coulomb charge flowing, not equal, it's in 1 second 1.69 times 10 power minus 20 charge coulomb is leaving. So what is the time required to get 1 coulomb of the charge? So now the problem becomes Simple. Now you can do the cross multiplication, that you can calculate this value of the time. So I can calculate that by taking the time to get time required to get a charge of 1 coulomb. Just you can do the cross multiplication, that is equal to, if you can take this as x, do the cross multiplication, x times 1.6 times 10 power minus 19 coulombs equal to, cross multiply 1 into 1, 1 coulomb second. You can divide x equal to 1 coulomb second divided by 1.6 times 10 power 9 minus 19 coulombs. Coulombs gets cancelled. If you can divide this, the value x equal to 1 second divided by 1.6 times 10 power minus 19. Finally, if you can do that in terms of division, x equal to 6.25 times 10 power 19 seconds. Convert seconds into years, the time x equal to 198.18 years. The time required to take out 1 coulomb of the charge at a rate of 10 power 9 electrons is almost 198 years. It means 1 coulomb of charge is huge. It's a very big amount. That's why we like to use lower units of the charges, like that 1 microcoulomb, 1 nanocoulomb, 1 millicoulomb. Micro means 10 power minus 6 coulombs, nano 10 power minus 12 coulombs, milli 10 power minus 3 coulombs. So 1 coulomb of charge is a huge amount, is the higher unit of the charge. We would like to use lower units, microcoulombs, nanocoulombs, and millicoulombs.